Hi, I'm Ryan Carfiello, Director of Corporate Accounts at PMR. Today we'll be shooting the second episode of Converters 101. We're going to be talking about oxygen sensors today. An oxygen sensor, also known as O2 sensor, is a small device that helps regulate a car's engine's airflow ratio. So why is an O2 sensor valuable? There's value because there's a small platinum rod found at the bottom of the sensor with small traces of precious metal. O2 sensors are platinum based, so you'll really want to follow the platinum market. Rhodium and palladium, even though they're very important metals in the converter industry, they're not found too much in O2 sensors. If you're looking for an updated price on O2 sensors, which is always going to be done per pound, you can go into our SSP online system under price list and the section O2 sensor. And from there, you'll see a price per pound that updates every minute according to the market. How to get paid for your O2 sensors. At your yard or location, if you pull them off the car or the converter itself and package them separately, we will weigh them up by pound and pay you on a per pound basis. If you do leave the sensors on the converters, unfortunately, you won't get paid for them. So how to pull off the oxygen sensor. The best method is to take an air gun with a 22-inch socket that fits right on the air gun, and with a click of a button, you really just zip it off. We're only looking for the oxygen sensor itself, so any wire that is attached, brackets, you really want to keep those for yourself and only ship the sensors. In terms of packaging, you can put it in a small 22-gallon bucket. Some companies put them in drums, and some even put them in gaylords after consolidating and accumulating them for a long period of time. There's not one standard size of sensors. You're going to have smaller ones, larger ones, some with brackets, some without. So you're not going to have a uniform sensor, but at the end of the day, they're all going to have that small platinum rod at the bottom, and that's really what we're after. So the next topic we're going to discuss is checking a converter's fullness. This is a very basic but crucial part of buying and profitably selling converters. It really applies more to our scrapyard clients or any company that's really buying a converter. Why is it important? So checking the converter's fullness is important because not all converters are made full. Some are manufactured as a half or 3/4. So that really plays a role in the value of the converter. A lot of the tools that you're going to use for pricing catalytic converters are going to always assume the converter is full, just because that company really at the beginning doesn't have it in-house or in hand. So to give an example, if a price point of a converter is $100 and for some reason the converter is half broken, half full, or let's just say made as a half from the factory, that converter is really only worth $50 because you're only getting about half of the weight, which is going to give you half the precious metals and half of the value. So rule of thumb, if it's a quarter full, assume a quarter of the full value. If it's half full, half of the full value, and 3/4 full, 3/4 of the full value. What are the best tools to use? You'll want to use a checking stick or device that you can really put in each end of the catalytic converters and also bring in back on top of the catalytic converter to make sure it's full. The best checking device we would find is a car antenna, just because it's going to be able to be long enough and sturdy enough. It's also going to be able to bend within the different catalytic converter shapes and types. Moving on to a converter that we call a branch unit that's going to have the pre and then the regular converter. You're going to find that sometimes this large unit is 100% empty and there's really only the value in the pre. So being able to find, as I said again, a device that is long enough that would actually go through the pipe, through the system, all the way to touch the end of the pre is going to be very important. So we'll give this one example. As you can see, the indent here, sometimes you might have to look at it on a different view, but this converter biscuit should be from here being full all the way here. So the biscuit is never really going to run up the pipe. It's not going to be outside of the shell. So generally you're going to find the indents and it's going to be inside the converter. So we'll give this one a check. Perfect. This one's full. And this one, it's going to be hard to check because you can really only check that the pre is full. So this one is full. Sometimes a good method here is just picking up the converter and shaking it. I'm giving it a really good shake and I don't hear anything loose whatsoever. So hitting this side being full, this side being full, I'm gonna assume that both converter biscuits are intact, but it would never hurt sometimes. Companies might wanna actually cut this open and then just do an extra check on each side to make sure that it's 100% full. So you'll wanna insert, and this one here, as you can see, is not going right to the end. It's going a little bit further. So that is really showing more half full. So again, this value, let's just say it was $200, and the rod on this side goes halfway in, it's gonna only be valued 50% less at $100. And checking this side, you can see that the rod goes fully to the end. So this converter is actually only half full. You also want to use a flashlight so you can actually see inside the converter, you know, for places that are a little bit darker, maybe buildings that are not lit as well. So a flashlight and a checking device are going to be your two best friends. In our industry, an average load is made up of about 4 to 5% broken or partially broken converters. That's just a good average, let's say, in our industry. So anytime you're really getting over that 5% threshold, 6, 7, anywhere higher than that, you really want to look at your converter loads in terms of how you're checking it, maybe which employee's checking it, because the concern there is that someone might be dumping or bringing a lot of non-full converters, and your buyers at the scale or yard might be assuming they're full and really overpaying just in terms of that value. I've done a lot of in-yard training seminars, and I always give the test. I'll look through a pile of converters, I'll hand it to a buyer, and I know that this converter, let's say it's a Nissan that's made as a 3/4 full unit. I'll give it to them, and the first thing they do, because there's a wide enough gap, is really look inside, and they'll look inside of both ends, and they'll give it back to me saying that it's full. So it's a good way to keep them humble, because I'll show them that, you know, when you really take that stick, you put it inside, really that difference between 2 or 3 inches could be the difference of a 3/4 full unit or a full unit. And that value could be, you know, upwards of $50+, sometimes just from that 2 or 3 inches. So you want to make sure that you're checking every single converter and not just holding it up, because a lot of converters are going to feel dense, they're going to feel heavy, and they might look like looking down the line that they are full, but they're not always full. So I think working from the ground level, you know, managers and owners really want to be checking their converter loads. Hopefully work with a processor that gives you a detailed breakdown of how many quarter, half, 3/4 full, and even empty converters are in your load, because you want to use that partial percentage, as we call it, PMR, and really make sure, is it around that 4 to 5% mark or lower. So an average load in our industry is made up of about 4 to 5% partially full or broken converters. Anytime you're really under that 4%, it's going to mean that the load is not really broken up that much. Anytime you get a little bit higher, 6, 7, 8, if you hit 10% or higher, you definitely want to look into it, because either two things. If you're actually dismantling the converters yourself at 10% or anywhere near that 10% threshold, you're probably not doing a great job at dismantling them. You're maybe ripping them, not using the proper tools, and that's going to affect profit essentially. But if you're really buying the converters, you want to make sure that a lot of peddlers are not bringing you half full, quarter full converters, and your buyers are assuming they're full and maybe overpaying just from the fact that they're assuming the unit's full. So it's a really important stat to check, and I personally don't see a lot of companies diving into the partial percentage. So here at PMR, we do process and assay different material types. We find that it's much more accurate, and it's going to give you a lot more data when you run an assay recovery on your different material types. So we do not mix our OEM ceramic with our aftermarkets or foils or DEPF. They all have different compositions. They all have different PPMs. So what we find is it's better to obtain your assay on each material type. There are some companies that do mix it together. We caution against it just for the fact that they're so different in terms of the composition and the PPMs. For example, aftermarket are going to be much lower grade PPMs. You're going to have diesels that are going to be basically primarily in platinum, palladium, no rhodium. You're going to have foils that are going to be so high in PPM instead of in the hundreds, they're actually gonna be in the thousands because they're just made of dust. So again, imagining going into your laboratory when you have foil dust, when you have DPF, you have aftermarket, you have OEM ceramic, trying to mix that together and get a blended, accurate sample with so many moving parts, so many different materials, it's not gonna be, for us, the most accurate. So at PMR, we like to process per material type, assuming that you do have enough weight to get an assay per material type. We find that it's gonna be a much more accurate assay. Your data and your tracking is gonna be much better because you're gonna know your recoveries and you're gonna know your ounce returns per material type. So we find it's much better to process an assay per material type. Thanks for your time. Always a pleasure. Stay tuned to the next set of videos.